Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois, and this video today is going to take a look at problem solving from two different perspectives. So I took the problem we did from, or I did at least, from the Matthew Scroggs Puzzle Advent Calendar. You'll see the problem here in a couple seconds. And I forget which day exactly, probably day 5, somewhere around there. Obviously, I can say somewhere between the first 5 days or 6 days or whatever it is. And so we're going to take a look at the problem from the computer science side, see the pluses and minuses of that, and then we're going to take a look at the things from the mathematics side of things. So here is the problem that we're going to look at. So when I take the number 12,345 and divide it by some number, I get a remainder of 205. So this number is going to be x, obviously. And when I take 6,789 and I divide it by that same exact number, my remainder is 112. So the question is, what is that number where both of these things come out true? And so you can already see the answer here. And if I run this, you can obviously find out the answer. And so the answer is 607. And all I really have to do is test from the range of 1 up to and including the larger of the two numbers, because it really doesn't make any sense to go higher, and I could probably even go lower. And again, I am a computer scientist and I'm learning mathematics every day. I'm doing these kind of problems. I'm learning something new, and that's why I'm making this video for you guys too. So if it's new to me, maybe it's new to you as well, and maybe it piques your interest in trying to look into the mathematics side of things, depending on what your perspective is and where you're coming. So I try every number in here, and I brute force it. The computer is great at brute forcing things, and so I just solve this and go, if both of these things are true, print out the answer, and the answer is 607, and do the math. Divide 12,305 modulus 607, you get 205, and 6789 mod 607 is 112. But this is where in my previous video I said this too. I'm like, there's got to be a better way, or at least there's got to be a way to get some understanding of what we're trying to accomplish, and an algorithm, a mathematical algorithm, rather than just trying every combination of numbers and just going with it and just going, oh, it's 607. And so by brute forcing the solution to the problem, we really didn't learn anything at all about the underlying mathematics. So like if I had absolutely huge numbers, like if I want, like the numbers in the trillions or numbers in the quad, whatever they're called. I haven't played clicky games in long enough. Like absolutely humongous numbers, integer numbers. And I wanted to figure this out. It would take forever because I'm trying trillions. I would be trying trillions or zillions or multi-zillions of different combinations. And it doesn't really get me anywhere. Like it's going to take me forever to solve this problem. As much as it solved the problem pretty quickly, that's only because these numbers are quite small. So I didn't learn anything about the underlying mathematics. I can't solve larger problems in a reasonable amount of time. And that's where a lot of these advent of code and just puzzle advent calendars and all these kind of puzzles, I really like these, because at least with advent of code, like the solution to the part 1 problems generally can be solved using just pretty much any algorithm at all, like any valid algorithm, because the data sets are small. And what happens is once you get past part 1, they up the ante on you, and part 2 is generally like, well, if it worked for 10 things, how would you make it work for 1 trillion things? And it's like, well, my algorithm no longer works for that, because it would take, like in this, it would take millions of years to solve that problem, or the computer doesn't have enough memory to be able to do that kind of problem in the way that I set up my logic and the programming. So there's got to be a better way, and that's where the mathematics of this is going to come in. And let's take a look at the same exact problem from the mathematics side. Okay, so here's the problem. Here's everything we're starting with. So if I take 12,345 and I mod it by x, I get the number 205. And if I take 6,789 and I mod it by the same number, I should get 112. And so that's it, right? You sit there and you're like, now what? And so I think what's pretty cool about this is now, if you start, the internet is a great tool for something like this, and here is something like this. basic understanding of congruences is something that I never really worked with because, of course, I did math up to a point, but I didn't really do anything like this. And so there's a whole realm of mathematics for these type of congruences, and modulus operations play a great role in quite a few topics of mathematics and computer science. So it makes sense to, it makes sense to study this out for a little bit of time. I think I spent an hour and a half total on this, just kind of learning from this so I could explain it to you guys. And so there's a way of putting this out into the mathematical understanding here. And again, if you're coming from a math background, you probably have seen this. And I think, black pen, red pen, and oh, forgive me for not remembering the person's name. His name is something Penn. I really do enjoy watching their videos when it comes to just these kind of mathematics problems. But between congruences and integrals and derivations and things like that, I've been learning a lot from these guys. So I highly recommend this. So and he could use some more subscribers. He deserves some more money for all this hard work he's been putting in for us over the years and continues to do so. So I can say that two numbers are equivalent to one another if I divide by some number n and I get the same remainder. That's what this is saying right here. And so I can take my problem, my two problems here, and I can go ahead and change up the formula so that we can start working from there. So these two formulas convert into something like this. 12,345 is, I'm going to use equals, even though this is like the triple equals. I'm not going to go ahead and put it in that character. It's congruent to 205. Because at mod x. And that just is say you can watch the video if you're interested. It's only a 6-minute video. Mr. Red Pen, Black Pen. And so there's no reason for me to describe every detail of the mathematics when that is done for you by a mathematician. This is done to you by a computer scientist, but I'm at least showing you how you can get from point A to point B here. So this is how you switch everything around. And what this is now saying is these numbers are, you can't just pick any x and expect this to work. But the x that works means that if I take this number and divide by here, I'm going to get the same remainder as if I take 205 and divide by that. So this is basically a number, and this is most likely the smallest number that divides in. And so the same goes for here. So this is the first step of that understanding. And so now the next step here is to take another step back and go, what does that all mean? It means that if I take whatever my x value is and I multiply it by some constant, and I'm going to call that k. So k times x. And if I go ahead then and I add 205 to it, I'm going to get, I'll put it on the other side, I'm going to get 12,345. So, and I know it's like, what am I doing? But it's just saying that if 205 is a solution to my little problem here, that if whatever x is, if I continue to add x to it an integer amount of times, when I get there, when I get to, and I keep going and add that value, I will get 12. I will eventually work my way up to 12,345. And the same goes for over here, where 6,789 is going to be some different constant. I'm going to call it m. I hate L because it gets confused with ones. And if I take that and 112, so if I take 112 and keep adding 112, 112, 112, 112, 112, I will eventually get myself to 6,789. But it all depends on what this x value is, and that's what we're trying to solve. If we could solve it that easily, we wouldn't be talking about this. So we now have two separate equations. We have basically three unknowns at this point. We don't know k, we don't know m, and we don't know x. So in a way, we made the problem even more complicated. But coming back to his video here, this little guy right here is the amazing part. If I subtract the smaller number from the larger number, whatever my x value is has to divide into it. And so coming back here, what that means is that my x value has to divide, I'll use the pipe, into 12,345 minus 205, or 12,140. And over here, my x value has to be divisible into 6789 minus 112, which is 6,677. It just I know it just seems like we're getting into bigger and bigger trouble, but I promise you that this is going to come around real quick here. So whatever my x value is, let's say, has to be divisible into 12,140 and also divisible into 6,677. And you're like, well, now do we brute force now? As I say, the computer scientist goes, when do we brute force this? And you go, never. There's no need to. And like, okay, and this was the cool part for me. So it's like, well, how do we work our way down to this? So the final step here, and you know what the answer is. You know the answer is 607, and I'll even bring this up right now. You'd be like, oh, the answer is 607 because we know that. We learned about congruences, and I'm going to show you about the greatest common divisor we're going to be using for this. And as you can see here, but if you do this problem, you're learning a great deal about the underlying mathematics of congruences and all these things that we're talking about. So what I have to do is how about I take 12,140 and break it into its prime factorization, which comes out as 2 times 2 times 5 times 607. What do you know about that? That's a prime number. So 2 times 2 times 5 times 607 is 12,140. What about over here? X is divisible into, the prime factors of this are 11 times 607. And so if you take a look at this, and you don't even have to do it through a computer, you can obviously tell that the greatest common divisor of both of these numbers is 607. And so without doing any computer work, just kind of thinking things out here, we get ourselves to the 607 value that we're looking for. So now I've reworked my code from previous. Remember, it was all brute force now, but we're doing it smart. My end goal is to end up with a list of values like the 12,140 and the 6,677 and just work my way and give me the greatest common divisor of those two numbers and get me that 607. And that's what this thing does. So now the user could go in and modify the values inside this list of lists. Here is the A value, here's the B, here's the A, here's the B. And for every one of these values list inside list, for every element of that, take this number and subtract off that to get me those values and store it in a new list. So the differences will hold two values, and I just go ahead and get the GCD of those two values, just like we did earlier. We didn't really technically get the GCD, we just stared at it and go, hey, that number looks familiar. But behind the scenes here, mathematically now, the GCD for 2, 3, 4, 5, 6 different things will get me the solution that I'm looking for, because there is my winning case right there. And what's cool again is now, instead of having to think out for all these different possibilities and waiting 6 human lifetimes or 6 heat deaths of the universe for a solution, depending on the largest of the numbers, I just have to do a couple math operations, and as long as Python can hold that number in memory, then we have ourselves a deal, and we can do a series of equations. There could be 2, 3, 4, 5, 6, 7, you name it. And if not, then I'll rewrite the code. That's part of being a programmer. Is this code worked for what I needed it to work for, but does it truly work for harder, more cases, different cases? Like if it works for case of 2, does it work for 3? Does it work for 4? And at this moment, the answer right now is I don't know. But I just wanted to show you guys how you can think smarter and not harder when you're dealing with computer science and you're dealing with mathematics. And just a little bit of work on one end. If this was my job, like if this was my thing, yeah, it took me 2 hours to produce these 4 lines of code. But I can pretty much guarantee you that for what it does it perfectly, or at least with the test cases that I have. And which side do you fall on? Coming from the computer science side, for me, it always rings hollow when I brute force something and I go, well, I got the answer, but if something like this ever comes up again, I don't know really how to solve it. And so the mathematics side is great for that. And there are tons of uses for this kind of math moving forward, for all sorts of different algorithms that we use. The modulus arithmetic is used a crazy amount in algorithms out in the world. So that is all I wanted to cover here. I just wanted to show you that computer science and mathematics can work together. They can, right? It doesn't have to be Mortal Kombat. Put a mathematician and a computer scientist in a room, and it doesn't have to be an all-out battle. We can work together. We absolutely can, because at the end of the day, a computer scientist is an applied mathematician who who at some point decided that didn't want to work so hard to learn all the math, right? Maybe I'll get myself into trouble about talking. That was at least me for a long time, just because the theory behind everything just didn't click as a 20-something, and now as a, let's not say, as a getting older guy, that the underlying mathematics, like the underlying understanding of what's working, matters more to me than just finding an answer. So as always, if I misspoke about something, or if you have any questions, concerns, comments, please comment below, or you can always email me at swardbeat@cod.edu. And again, I highly recommend, for any kind of mathematical topics, Mr. Black Pen, Red Pen. Do I have it in here somewhere? What is his name? And the math guy. I don't know what's going to come up. I apologize. Let's see, Penn Mathematics, and Michael Penn. I do enjoy his work as well when it comes to sometimes I watch this and I'm like a lot of other people where I go, what in the hell's going on? But at the end of the day, it helps me learn a little bit more about everything that we're doing out in the world. So thanks for sticking out with me, as I was saying. Hope to see you guys in future videos. Thanks for sticking it out. Have a great day. Take care. Bye-bye.